Hi Science 10. Here's our first topic in Chapter 3 on chemical reactions. And we'll start off with looking at what a reaction is, and that is when substances have changed in their chemical form. And so they have undergone a chemical change, and there will be a new product or products formed when a chemical reaction has happened. So you will have to know the types of evidence that indicates a chemical reaction. If there's been an odor given off, a color change, bubbles given off, precipitate, so a chunky solid that is formed. If the temperature or energy change has happened, so that could be temperature getting warmer or colder, production of light like a flame, some sound or electricity produced. Those are also evidence of a reaction having happened. So the next concept here is about solubility, and we have a solubility table that I would like you to locate on your large periodic table, your large white one that you folded in half. That is the solubility table that you would use as your data sheet for assessments. So please refer to that, just so that you can see what it looks like. It would be this one that we'll be using to determine whether the compound is solid or if it's aqueous, which is dissolved in water. So it says when you mix ionic compounds, the new substance may or may not dissolve in water. And so when products are formed, we'd like to be able to indicate their state as being solid or aqueous. When you see a chunky yellow substance floating as a new product that's formed when you mix two clear liquids together, you definitely would call that a precipitate, and the state of that would be considered solid. It would be like something solid floating on the top. And to determine whether we indicate it as a solid or aqueous substance, you would just use your solubility table and locate either one of the ions in the compound at the top of the chart and look down to see where the ion it's combined with is located in the chart. And I will just go to our table right here, and let's say that we're talking about silver bromide, for example. Let's go with silver bromide. If we were using that one, silver bromide together, we found that when they're together, you found bromide over here and silver over here, indicates that it has a low solubility. So anything in this area would be written as a compound that's solid. It would form a precipitate. It says most things though with bromide, anything besides this group would be considered to have a very high solubility and dissolve in water very easily. So we would indicate the state as being aqueous. So we're going to try a few more of these examples here. When you're thinking of something like hydroxide, it just says that when hydroxide is anything, it was with any of the group 1 ions. So when it's with hydrogen, HOH would make water, so for sure that's aqueous. But including lithium, sodium, potassium, that whole group 1 ion group, and ammonium, when it's with hydroxide, it would have the state aqueous. However, anything else that hydroxide is with, so most things, because only these make it aqueous, hydroxide with anything else would actually have the state of solid. So let's give some of these a try by copying down these 8 compounds. And I'd like you to pause the video, copy these down, and we will then you can play the video. I'll show you how to get started on this, and you can pause it at any time to try it by yourself. So sodium hydroxide, the first one, looking at this chart, sodium with, hydroxide ion here with sodium, which was a group 1 ion, would mean that it is going to be aqueous. So we go over here and we say this would have the state aqueous. For calcium phosphate, let me just change to a different color. Calcium with phosphate, we find phosphate over here, and it says that with the group 1 ions or ammonium, it would be aqueous, but anything else, it would be solid. So mixing it with the calcium would come into this category, so we have to assume that it will be solid. So we write solid as the state for calcium phosphate. For sodium hydroxide, again, it says here that group 1 ions, with which sodium is, mixed with hydroxide, sodium and hydroxide would be aqueous because it's a group 1 ion. Calcium hydroxide, going back to our hydroxide area, calcium hydroxide would come into this category here, of being a calcium hydroxide would be over here because hydroxide, let me just see something here. Calcium, I thought it had another category, another spot where it's found, but that's only for fluoride. So hydroxide with calcium, calcium would come into this area, so we'd write that as solid. Right over here. And sodium nitrate, if we find nitrate over here, and it says most things with nitrate are going to be aqueous, so we'll assume that with sodium that would be that category because sodium is not found in here with nitrate. So sodium with nitrate would be aqueous. Aluminum sulfate is our next one, and SO4 and aluminum with SO4 is going to be found somewhere. Or is this the one that we don't have on here? One moment, please. Yes, it's right here. And aluminum is not in the category with solid over here, so we'll assume that aluminum would be in that most category, and so aluminum and sulfate will be aqueous. Magnesium hydroxide is going to go back to our hydroxide area, and its magnesium is not in this category, so we'll assume magnesium is the most in the group of most things with hydroxide are going to be solid. So we go down here and we indicate solid. Ammonium chloride is our next one, and we have chloride right here, and it says most things are ammonium isn't in this group down here, so we'll just assume that ammonium would be in the category of most things with chloride are aqueous. So we go down here and we indicate aqueous. That is our examples, guys, for using the solubility table, and you can practice up with the practice page in your notes. Bye for now.